Yes, it says I'm live. Excellent. Okay, time is flying by. First, we have 6 class periods. 6 class periods until midterms. I kind of filled out my calendar a little bit right here, but you can see that big block of midterms right there. 6 class periods until said time. I do have various things that I am planning. My goal for today, I would like to start out with a review quizzes, just to kind of get the ball rolling with some information that we have seen in the past. What I'm going to suggest, as I've told other people, if you're in the classroom, yes, have that Chromebook logged on immediately, but I'm also going to strongly suggest that you have a piece of scrap paper or you do some of these problems in a notebook just so you can have the ability to write out something. I'm not collecting anything, but there are going to be some problems that you are going to have to write out something in order to get it done. So I'm just giving you the heads up beforehand so that you don't have to go clamoring for a piece of paper during said quizzes review that I would like to knock out in the first part of this class period. Now, after we do said quizzes, I'm going to be looking at some of the red colored questions. Not all of them, but some of them, just to see where we're at. And then I will be talking about something slightly brand new today, which builds upon what we've been doing for the past several class periods. So get on to joinmyquiz.com. Chapow, start this classic, continue, boom. There is the code for all of you. For those of you that are in the live stream right now, I'm trying to type that code. There it is, into the chat. Of course, I'll write it on the board as well. 608224. Now, this quizzes is going to be reviewing certain key pieces of information with composition functions. Composition functions, we did a lot right before break. Composition functions we came back to on Monday. And I would like to review some of that stuff here with you today. Now, ultimately, like I said, I may not be able to go over every single problem, but I would like to go over at least a few questions, the ones that we struggled with the most. This is just a practice. This quizzes. This is just a practice. But I expect, obviously, we're putting forth our best effort on that. Now, I'm not going to give you a lot of time because I have other things that I need to get to. So I will give you the heads up when time is running short. But let's get logged in. We got 1, 2, 3, 4, 5, 6, 7, 8. I got 8 in here. I got 6 right there. But there's more people online. Waiting for them people to log in. Oh, wait, no. There's like usually like a button or something you got to click. All right. For those of you that have not logged on yet, obviously, hold on. There's somebody talking.
Please excuse the interruption. Can I have somebody from technology or Mrs. Haviland, please call the main office. Kelly, Frank, or Michelle, please call the main office.
Okay. If you haven't logged on yet, please make sure that you do so. I'm going to be walking around double checking things a little bit, but I want to get this started for those of you that are already there. The code will be written at the top in white once I click that thing. But let's get moving with it. So, click. I know. My warm personality. A lot. Both sides. freeze on there? For those of you that are still working, I'm going to give you just another couple of minutes to kind of wrap this up, and then I would like to review a few of these problems before I talk about the newer things for today. Okay, I'm going to end the game here just so we can get moving with what I needed to get moving with. Click, click. Excellent. Okay, so what I need from you into our notebooks. So the Chromebooks, you can close those up, put those aside, and I'm just going to need those notebooks out and open in order to get the next part of this thing done. So close up them Chromebooks and take them out those notebooks. Let's see, 3, 7, nice, 11. Okay. And that one and then that one. Nice. Okay. So as I mentioned, I would like to talk about, I'm just labeling my notes that I'll show you in a moment. I just want to get this first question written down so that you can see it a lot better than what it is on the board right now. There it is. And boom. There is the first question that I would like to review from that particular quiz. The question that they asked wasn't so much for you to actually complete the composition, but the question that they asked was to perform the operation f of g of 4. Now, there's two ways to go about a problem like this, two specific ways to go about a problem like this. I want to show one of the more basic ways right here. First, here is the outside layer of f of x. Right there is the outside layer of. So instead of x, I am going to insert something into those blanks. But I left that framework of blank squared plus blank. In that blank, I am going to put 3x plus 1. Now, normally, if I was just simplifying this thing down, I would have to multiply out 3x plus 4 times 3x plus 4. I'm not actually going to do that for this problem. Because since they want me to evaluate it at 4, I am going to take the next step of just plugging a 4 in for all of those x's. From here, it's just a matter of the order of operations. Inside the parentheses, I get 12 plus 1, which clearly is 13. And over here, it is also a 13. 13 squared would give me 169. 169 plus 13, well, that should give me 192. No, 182? Yeah, 182. There we go. Fixed it. Let me double check the quizzes just to see that 182 actually was one of the choices. Yep, there it is. And you can see it right there. 182 being the one in green. Sometimes it does take a little bit of a process. There is an alternate way of doing this, and I'm not going to write it into my notes, but I'll put it up on the board just so you can kind of see it visually. The alternate way of doing this would just first simply do g of 4, which would be 3 times 4 plus 1, which is 13. Then you would just evaluate f of 13, which does get you the same combination, or the same calculation, I should say. It just takes it in a slightly different track. Some people prefer doing it the way that I wrote into my notes. Some people prefer doing it the way that I just wrote out in red. It's up to what you prefer, but clearly either way is getting you the same correct answer. Let me take a look at another one. There are 3 specific ones I wanted to look at. Yep, there's another one right there. So let me write this one down, and then I can flip my screen over. The problem gave you f of x equals 3x plus 5, and g of x equals x minus 7. They're the problem. That's the problem right there. They give you a new f of x, they give you a new g of x, and they expect you to perform the correct composition. Now, I'll check what answers you guys, or most of you, picked in a few moments. But I wanted to see this one just because it was indeed colored in red. The outside framework is f of x. So the first thing I do is I draw the shell, the outside framework. The f of x framework is 3x plus 5. That x will be replaced with the g of x function, in this case, x minus 7. I'm just leaving that framework there so people can visibly see it. Oh, that's the f of x with nothing plugged into it. But now there will be something plugged into it, the g of x function, which is x minus 7. From here, it's just a matter of simplifying properly. To simplify this properly, I can distribute that 3. And then I just need to combine like terms, which in this case should give me 3x minus 16. I'm going to double check the quizzes in a moment just to make sure, number one, that was one of the choices, and to see how many people actually picked it and what they picked. Let's see. Yep, there it is. Yeah, I can see most people actually ended up picking 3x minus 2. I can see why they would pick 3x minus 2. You saw the plus 5 and the minus 7, and you just decided, heck, I'm just going to add them together. But that's not what the question wanted. The question wanted you to perform the correct composition. I got at least one more that I want to try here. I gotta find it now. It's there 11. Oh, that is a good one. Let me look at 12. Yeah, you know what? Let's do that one. No. I do like that one. Let's do that one. Cool. We're doing 15 then. I'll do 15 to kind of wrap this up, and then I'll talk about the new thing I want to talk about. Writing down the problem first, f of x. It's h of x this time around. And they want f of h of x to pound. That's the problem right there. Now, for this problem, it does get a little trickier in terms of simplifying this thing down. It does get slightly trickier. Simply because there is an exponent that is involved with plugging this junk in. Well, they want, in that particular order, they want f of h. And since they want f of h, again, the outer framework, there's the outer framework right there. The outer framework being the f of x function. There we go. What's going in that framework is a 3x plus 3. Now, based on everything that we've done, you are not allowed to distribute that exponent. You're not. You are not allowed to distribute that exponent. Instead, in order to properly simplify this problem, you are going to have to multiply out 3x plus 3 times 3x plus 3. Well, from there, if you do multiply it out correctly, 9x squared plus 18x plus 9, with that minus 4 being tagged on at the end. You could FOIL it. You could use a 2x2 box. Either way, that's what we get. Simplifying this thing down completely gets you that quadratic, which I'll double check on the quizzes in a moment. Let's see. Yep, there it is, the bottom one. 9x squared plus 18x plus 5. Again, I can see a lot of people getting that first choice. Yeah, they would have thought 3x squared plus 9, and that then the minus 4 comes into play. But yeah, that's what it should have been. And that's the process that should have been followed. Again, composition functions are going to play a role moving forward. I'm going to be assigning you something within probably before the end of this week, just as a practice assignment, homework assignment. But we'll see, because there will be assessments on the horizon, of course, in regards to this information. I'm going to keep those close to the vest for the time being. Okay. Here's what I want to do. With the time that we have left, I want to introduce to you a slightly newer concept. This newer concept, just to give you the heads up, will be a part of the midterm. There are 6 class periods until the midterm. Of course, we're going to be learning some new information. In reality, those 6 class periods turn into 4 because I would like to spend a little time reviewing with you before said midterm. But we'll get there. Let's call this graphing square root functions. Oh, I can't see it because the computer froze. There it is. Graphing square root functions. From the beginning of this school year, we started out using quadratics. We did everything with quadratics. We graphed quadratics, we factored quadratics, we simplified quadratics. We used the quadratic formula based on the quadratic equation. Eventually, we built up to polynomials which contain quadratics. The inverse operation of a basic quadratic is a square root function. When a square and a square root come into contact with each other, they cancel each other out. And before the end of this chapter, which the rest of this chapter actually will be taught after midterms, but before the end of this chapter, we will be solving some higher level square root equations. But we're going to get there. Right now, it's just baby steps until we get there. Let's talk about the function, the square root of x. Now, I'm going to flip over to my calculator in a moment just to show you what this looks like and what the table of values actually get you, which is nice. Let's see. Boom. Now, I put in the square root of x into my calculator. I need you to see what, number one, what it looks like, and number two, what the table of values actually show you. Graph. We've talked about this briefly before, but in reality, this square root function is nothing more than a parabola opening up to the side. It's nothing more than a parabola opening up to the side. But that bottom half of the parabola is not there. It isn't. Goodbye. There are various reasons why it's not there, but the most important reason has to do with the definition of being a function. Now, please correct me if I'm wrong, because I did not teach you Algebra 1. But in Algebra 1, did they ever show you anything in regards to a vertical line test? Ring any bells, vertical line test? That's okay if it doesn't. I have no idea who taught you Algebra 1. I have no idea. I may mention Algebra 1 and again, it might send shivers down your spine. I don't know. A vertical line test determines whether or not a graph is a function. And basically, if a vertical line can be drawn and it goes through more than one point, then that would not be a function. It would not work properly. The pure definition of being a function is that for every input, there is exactly one output. The square root function, unfortunately, then can only be half of that parabola. Furthermore, look at my table of values that I got up here. Look at my table of values that I got going on. Now, let me go back a little bit into this table of values. What the heck is that? I mean, I know they're errors, but like, what the heck? Why are there errors? There's a whole ton of errors over there. It just, there's a reason for it. Pick one of those numbers that give you an error. Pick one of them. -1. What's the square root of -1? What happens typically when you try to take the square root of -1? Yeah. You typically get an error. Now, when you take the square root of -1, what I have taught you in the past is that it does produce a complex number I. But you can't graph an I. I know. You can't graph an I on this XY plane. So it doesn't show up at all. To the left of that origin, nothing happens. Nothing shows up. So here's what the basic function will look like. The basic function will start off at the origin and will simply curve out like a parabola. But it will curve out like a parabola opening up to the side. This does not flatten out, just so you know. What I'm pointing to right here, it doesn't flatten out. It keeps going up and out forever. It keeps going up and out forever. In fact, I could say something like this. This is what they call the standard square root function, which I definitely need you to write down. This is the standard square root function. This is the standard square root function. Let me zoom in on this a little bit more and pull that up to the top. What is this? I did that. Whatever. I'll get to double check that. Anyway, with this standard square root function, it has some of the same mannerisms as to other functions that we've done in the past. It has that h and k situation going on once again, and it has that a value. Now, I'm going to put some things into the calculator for you to see visually in a moment, and it's going to include that whole h and k situation. Let's just see what it does. For example, give me two numbers, one negative and one positive in any order, doesn't matter. Give me two numbers. Give me your favorite two numbers. I don't care. 2 and 4. Make one of them negative. Doesn't matter which one. -2. All right, check this out. Watch this. Okay. Look what I just typed in. Now, in your calculator, you have to be very careful. Because when you type in numbers under that square root and outside of that square root, you better be clear with the calculator where you're typing it. I put the -2 underneath that square root, and you notice that that square root symbol is extended across the top. If you were using a basic TI-83 calculator, you would have to close off that square root using parentheses. But that +4 is clearly on the outside. Now watch what happens when I graph it. What happened to it? What happened to it? I guess nothing. Where is the starting point? Close. Think about the numbers you gave me. At +2, 4, though. You made the 2 negative, but it moved positive. There's a reason for that. There's a reason for that. Give me two different numbers. Give me two completely different numbers. 3 and 8. Let's make the 8 negative. Let's make the 8 negative. 3 and 8. Let me change this up. Oh, didn't get the x. Hold on. X plus 3. Ah, I hate this thing. Square root x plus 3 minus 8. There we go. Nailed it. Now watch what's going to happen. Graph that sucker. Oh, let me hit trace so you can see the equation in the top corner. Where did it move? Where did it move? You gave me plus 3 and minus 8, but where did it move? From the origin, how far to the left did it go? From the origin, how far to the left did it go? You could take a guess based on the numbers that you gave me. Yeah. How far down did it go? Yeah. This square root function can move anywhere it wants. And I like the idea that you guys called it the starting point, like where it started. Originally, it started at the origin, but you can have this thing shift in any direction you want. Not only that, check this junk out. Look at this. Look at this. Look at this. You can get rid of all that. And I'll do the negative square root of x. Look at this junk that I'm about to type in here. Look what I just put in there. I just put a negative in the front of this whole thing. Watch what happens when I graph it. This thing can flip completely upside down. In fact, there is a way to actually make it flip to the left. Let me actually do that real quick. You can actually make it flip to the left by putting the negative on the inside. It's really messed up. Let me go back to here. H comma K changes the starting location of the graph. H comma K changes the starting location of the graph. It shifts. The graph shifts H units horizontally and K units vertically. Move that up a bit. The graph will shift H units horizontally and K units vertically. The thing that you'd have to keep in mind, I'm going to put a little note here, a little bullet point here. Pay close attention to the sign on H. Pay close attention to the sign on H. And I'm going to show you another example of that in a moment. But the graph will shift H units horizontally and K units vertically. I'm going to flip back to my calculator in a moment. Chapow. Let's see. Square root of x minus 5 minus 3. Some junk like that. Now, in this instance, you got to pay close attention to the sign on H. Think about this in your head for a moment, because I'm going to tell you what the answer is after I ask the question. Think about the following question. I would ask the question, what is the value of H? The correct answer is positive 5. Let me repeat that. This is the part that most people get tripped up on the most. I say, hey, what's the value of H? And people, well, you should be answering positive 5. And the reason for that has to do with the general form, the standard form of this thing, where you have that minus H on the inside. That H value is just 5, meaning that it will shift 5 units horizontally. Since it's a positive number, it will be to the right. Now that K value is negative, meaning that it should shift 3 units down. It should shift 5 units to the right and 3 units down. Let me hit graph and we'll just see what happens. There it is. 5 units to the right, 3 units down. That is where this thing is shifted. It is insane. Going back to the notes, just a couple last things that I want you to write down. If A is negative, the graph will reflect vertically. If A is negative, then the graph will reflect vertically, meaning up and down. I'll show you a couple examples just to kind of nail that point home. But you have to pay close attention to the A value if it's negative. If the number is like a fraction or a different kind of positive number, we'll deal with that another time. But the main point I want to get across is the fact that if A is negative, then the graph will definitely reflect in a vertical direction. If I go back to the calculator, I'm going to go up to the board real quick just to draw something right here. That was a fun noise. Now this graph, I just wanted to put it there just in case something happens to it, in case something changes drastically. That is my original graph. That is the function y equals the square root of x minus 5 minus 3. It shifted 5 to the right. It shifted 3 units down. But now what I'm going to do is I'm going to insert a negative sign right in front of it. Going to insert a negative sign right there in front of the function. Now that negative sign is my A value. It's multiplying that square root by that negative, and I want to show you what happens to it if you put that negative in front of it, and it completes the rest of that sideways parabola. It doesn't just reflect it over, let's say, the x-axis or some junk like that. That's a different property altogether. But if that negative A is there, it will reflect the problem, but it will keep that starting point. It will keep that starting point. Let me actually put that additional note into my notes. Oop, there we go. So if A is negative, the graph will reflect vertically, but will keep the same H, comma K. It will keep the same H, comma K, even if that thing has been reflected vertically. The square root function is going to play a major role moving forward. We are going to be doing a lot of things with different types of roots that you may or may not be happy with. I will be absolutely happy, but I don't know how you will feel. Class is going to end in approximately 1 minute and 30 seconds. Actually, no, 1 minute and 20 seconds. So I'm going to wrap up here. But like I said, pay close attention to Google Classroom, as I may be posting something soon, and I want you to be aware of that. We only have a minimal number of class periods before the midterm. Make sure you're getting ready. I'm going to sign off.